Hello students, welcome back to my second lecture on basic maths. In our first lecture, we learnt some basic concepts on number theory like natural numbers, whole numbers, integers, odd and even integers, prime numbers, composite numbers and fundamental theorem of arithmetic. This theorem can be applied to find out number of positive divisors of a number, the sum of all positive divisors of a number. We also solved one example in our last class. Now we will solve some more examples. Let's get started. Find the number of positive divisors and the sum of all positive divisors of 60. That is solution. 60 is divisible by 2, that is a even prime number. We get 30. Again 30 is divisible by 2, we get 15. 15 is divisible by the next number, that is 3, we get 5. So the canonical representation of 60 is equals to 2 raised to 2 into 3 raised to 1 into 5 raised to 1. Now compare this with n, we get n is equals to p1 raised to alpha 1 into p2 raised to alpha 2 into p3 raised to alpha 3. On comparing 60 with n with the formula, we get p1 is equals to 2, alpha 1 is equals to 2, p2 is equals to 3, alpha 2 is equals to 1, p3 is equals to 5, alpha 3 is equals to 1. Now to find the number of positive divisors, we use the formula T of n is equals to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. Now substitute the value given, that is T of 60 is equals to 1 plus alpha 1 is 2, that is 1 plus 2 into 1 plus alpha 2 is 1, that is 1 plus 1 into 1 plus alpha 3 is 1, that is 1 plus 1. Now find the sum. 1 plus 2 is 3 into 1 plus 1 is 2 into 1 plus 1 is 2. Now find the product. 3 into 2 2s are 4. Again 3 into 4 is 12. We get the number of positive divisors of 60 is equal to 12. Similarly, one more sum, that is the sum of all positive divisors. We have a formula, that is S of n is equals to p1 raised to alpha 1 plus 1 minus 1 upon p1 minus 1 into p2 raised to alpha 2 plus 1 minus 1 upon p2 minus 1, so on till nth term, that is pn into p1 raised to alpha n plus 1 minus 1 upon pn minus 1. Now substitute their values, that is S of n here is 60 is equals to p1 here is 2 raised to 3 minus 1 upon 2 minus 1 into 3 raised to 2 minus 1 upon 3 minus 1 into 5 raised to 2 minus 1 upon 5 minus 1. That is equated to, here 2 raised to 3 is 8. 8 minus 1 is 7 upon 2 minus 1 is 1 into 3 square is 9. 9 minus 1 is 8 upon 3 minus 1 is 2 into 5 square is 25. 25 minus 1 is 24 upon 5 minus 1 is 4. Now that is equal to 7 upon 1 is 7 into 8 by 2 is 4 into 24 upon 4 is 6. Find the product. You get S of 60 is equals to 168. Now we will solve some more examples from exercise 1.1. First one, find the number of divisors of the following numbers. First one, 3 raised to 4 into 5 raised to 3 into 7 raised to 2. Here they have given the canonical representation. You just compare the distinct prime factors with the repeated terms. That is, P1 is equals to 3, alpha 1 is equals to 4, P2 is equals to 5, alpha 2 is equals to 3, P3 is equals to 7, alpha 3 is equals to 2. Now, the number of divisors of the number is equals to T of n is equals to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. There are 3 different prime numbers we have. So that is equals to alpha 1 is 4, 1 plus 4 is 5 into alpha 2 is 3, that is 1 plus 3 is 4 into alpha 3 is 2, 1 plus 2 is 3. Multiply these 3 numbers. 5 into 4 is 20, 20 into 3 is 60. So this is the answer to find the number of divisors. Similarly, we will see next sum, that is a little higher numbers. So second one is 4896. So the even number is always divisible by even prime number only. So divide it, once you divide it by 2, you get 2448. Again, this number is divisible by 2 only, you get 1224. Again, this number is divisible by 2, you get 612. 612 is divisible by 2 only, you get 306. 306 ended by again an even number divisible by 2, you get 153. So here it is ended by an odd number, so divide it by 3. 3 into 5, 15, 3 ones are 3. So 51 is divisible by 3, you get 17. So 17 into 1 is 17. So the canonical representation of 4896 can be written as 2 is repeated 5 times into 3 is repeated 2 times into 7 is repeated once. Now T of n is equals to 1 plus alpha 1 is 5 here, into 1 plus alpha 2 here is 2, and into 1 plus alpha 3 is 1 plus 1. Now find the product, find the sum first, then find their product. That is equals to 1 plus 5 is 6 into 3 into 2. After multiplying these 3 terms, you get T of n is equals to 36. Similarly, third one, that is 1644. Again, this number is ended by an even number, so divide it by 2 only. We get 822. Again, divide it by 2, you get 411. So 1 is last number, last digit is 1, it is ended by an odd number, it can be divisible by 3 odd number only. Then you get 137. So 137 is a prime number, so it has only one factor, that is 137 into 1. Now the canonical representation of 1644 can be written as 2 raised to 2 into 3 into 137. So after this, T of n is equal to 1 plus alpha 1 is 2, we get 3, into 1 plus alpha 2, you get 2, into 1 plus alpha 3, you get 2 again. Now find the product of these three numbers. You get T of n is equals to 12. I hope students are getting these sums. Next one. Find the sum of all positive divisors of following. First one, 672. Students, here I have done directly by taking the canonical representation. But you must do it separately and practice it. 672 have the factors as 2 raised to 5 into 3 raised to 1 into 7 raised to 1. Now compare this with our n formula, that is P1 is equals to 2, alpha 1 is equals to 5, P2 is 3, alpha 2 is equals to 1, P3 is 7, alpha 3 is equals to 1. Now they ask you to find only sum of all positive divisors. So directly substitute in Sn formula, that is equals to P1 raised to alpha 1 plus 1 minus 1 upon P1 minus 1 into P2 raised to alpha 2 plus 1 minus 1 upon P2 minus 1 into P3 raised to the power alpha 3 plus 1 minus 1 upon P3 minus 1. Substitute the values. You get 2 to the power 6 minus 1 upon 2 minus 1 into 3 raised to 2 minus 1 upon 3 minus 1 into 7 raised to 2 minus 1 upon 7 minus 1. In the next step, 2 is multiplied 6 times. Then you get 64. 64 minus 1 is 63 upon 2 minus 1 is 1 into 3 square is 9. 9 minus 1 is 8. 8 is divisible by 2. 3 minus 1 is 2 into 7 square is 49. 49 minus 1 is 48 upon 7 minus 1 is 6. Now 63 into 8 upon 2 is 4 into 48 upon 6 is 8. When you will multiply, when you simplify these three, you get S of 672 is equal to 2016. Next sum. Give the canonical representation of the following. Here they have asked only to find the canonical representation. So first one is 96. So 96 is ended by an even number. So divide it by even number only. That is, when you divide it by 2, you get 48. 48 is divided by 2, you get 24. Again divide it by 2, you get 12. 12 is divided by 2, you get 6. 6 is divided by 2, you get 3. 3 is divided by 3 only. So the canonical representation can be written as 96 is equals to 2 to the power 5 into 3 raised to 1. Similarly, second sum, that is number is 140. 140 is divisible by 2, you get 70. 70 is divisible by 2, you get 35. 35 is divisible by 5, you get 7. 7 is divisible by 7 only. Hence, the canonical representation can be written as 140 is equals to 2 to the power 2 into 5 into 7. And the next sum is, the number is 156. So 156 can be divisible by 2, you get 78. 78 is divisible by 2, you get 39. 39 is divisible by 3, you get 13. And 13 is divisible by 13 only, you get 1. So 156 can be represented as 2 raised to 2 into 3 into 13. Students, Maintain a book and write a notes given on this video. With this today's session we will conclude. We'll meet in the next session. Thank you.